Hey everyone, in this video I'm going to teach you everything you need to know about middleware. We're going to start slowly by learning about a few functional programming concepts which are core to knowing how middleware works, and then we're going to build our own pipeline, which is going to be quite an exponential increase in difficulty from the beginning. But once we get there, we'll essentially relax with looking a little bit at the ASP.NET Core middleware, how they do it, at the HttpClient middleware. We'll look at that. We'll take a look at some interceptors for axios and the Angular HTTP client, and we'll also, just for fun, do the same middleware pipeline that we're going to implement in C#, but in JavaScript, okay, just for fun. Alright, so C# middleware tutorial. We're going to start with learning about some functional programming paradigms, and essentially the first one is that we can treat a function like a variable, okay? So the way we store a number, we can store a function as a variable, okay? So that's the primary concept that we're going to try to get around today. And why do you want to store a function like a variable? Well, first of all, let's go ahead and create a function that we can execute, right? Public void first function, where we are going to say that executing first function. And let's go ahead and dump this. We're going to be outputting it like so. By the way, if you don't know this program, this is called LinkPad. I'm going to leave a link in the description if you want to go ahead and download it. But yeah, essentially, we have a function. It's called first. What we want to do then is, let's say, this is completely unnecessary, but let's go ahead and just wrap this with start, dump this, and then we also want to know when this function ends. Okay. So when we output this, we can see when the function starts and when it ends. Let's say we have a second function, okay? And we're going to look that the second function is executing. We're going to copy this and let's put it down here. And let's say we're now going to do the same but with the second function, all right? So we start and end and start and end. So the whole thing about programming is we are trying to alleviate repetition. A lot of repetition is bad, and you're essentially repeating yourself. You're doing double the work. You don't want to be doing double the work. You want to work smart. The primary repetition is that a function is wrapped with a start and ends. Okay, so this is where we want to pass a function as a parameter into another function, essentially wrap some work in another work, right? So a function is something that you're going to do, and let's say every time you do this thing, you also want to do this thing. But then let's say maybe you're going to do that thing, but before you do that thing, also do this thing, okay? So let's go ahead and just say that we want to wrap, and what we're going to do is grab this, but here we're going to replace this with a function, okay? And because we're going to be passing it as a variable, we're going to use lowercase, but we don't have it here, right? And the way you invoke a function is you call the parentheses. So how can we pass the function as a parameter into this function? There are two ways. There is the old way with using delegates, which is essentially like an interface for a function. Okay, so we can create a public delegate, and delegate, it's basically an interface, all right, but for a function, all right? The same way that you create an interface, this is you're creating a interface for a function, and then you specify the signature of the function. So the signature of the function is how many parameters does it have and what return type does it have, right? So return type is void toWrap. We'll just call it toWrap because I'm going to leave this in a second, and it passes no parameters, okay? So now we essentially created a interface toWrap for a function. So what we can do is we can say that we're expecting a toWrap in here, and this is going to be a function that we can execute. So what we're expecting to do now is we're expecting to be able to pass these functions into here, and the reason we can pass them is because the toWrap interface says that this function that is just an interface for a function is just named toWrap. It says that we're expecting a function with a signature that has no parameters and that returns a void, okay? So let's go ahead and call wrap on the second one first here, and then we're going to pass second, right? And this works because we don't call this function, we just pass it as a parameter. So it's just the name of the function, and that basically passes the function as the parameter. As soon as we would call the function, it would execute first before executing this function, meaning if it executes here, it returns a void. So we don't want to return void, we want to return the function. Okay, so there we go with that. And now we go here, pass first here. Let's go ahead, semicolon this off, and let's run this. And we're at the same point, right? But now we essentially reduced the duplication of wrapping our function with start and ends, and we can go ahead and create a dozen more functions. And for each extra function that we add, we essentially reduce 2 lines of code. So coming back here, another way to supply a function as a parameter is to use a more newer pattern called using a type called an action. It's a little bit newer and seems to be used everywhere. Nobody uses delegates anymore. So we no longer use delegates. What we say is we expect an action, and this compiles, right? So this works. And let's say that what if we want to pass a parameter into here? Because what an action says is we expect a void function, because there's a clear distinction between a action and a function. So for example here, an action, or otherwise known as kind of a method, doesn't return anything. So there is no return type. Okay, if we would have supplied a func of int, right, this means it must return an int. Okay, so whatever we're supplying here must return an int. Okay, and now this compiles, but we're not providing or we're rather not returning, so it's complaining here. Okay, so we're not going to be touching on these funcs, but essentially understand that actions don't return anything. So the only thing you can fill in the action is something that that is void. Okay. And if we want a signature that has a parameter, so for example, if we pass in an integer, you can see this no longer fits. So we can go ahead and add an integer here. So it's a function that expects an integer. So then we pass an integer into that function from the wrap. But you can see this first one can no longer fit this, because it basically says by specifying a type here, we're stating that the signature of the function should accept an integer as its first parameter. And then we can do the same for if we have more than one parameter, right? So string a, now it will essentially fit. We cannot swap these around, so these have to be in the correct order. Okay, so you can see it doesn't compile. So that's essentially kind of it to the action. We're going to stick with the more simple example here. Let's go ahead and rerun this. And now let's go ahead and wrap the wrap in a try. Okay, so we're going to create another function where we're essentially going to put the wrap function inside a try function. Okay, so let's go ahead and try. And again, we're still going to do an action, and we're still going to call it function. And what we're going to do here is a try catch. We're going to call the function. And let's say that we are trying here. And we're going to catch at the end. We're going to catch an exception. We're not going to throw exceptions, but we're just going to make sure that we're catching it, right? So we have a little try. So how do we put the wrap action, because the signature here doesn't really match the signature for this action. But what the problem here is that if we change the signature of the try function to essentially be of type action, it's essentially we're expecting a function that has a function as a parameter. Okay, what we're doing is we're breaking a chain of these functions, the ability to chain these functions. Okay, we're breaking it because the signature is starting to be different. Okay, and that's the primary backbone of the middleware, to be able to chain these functions, to have the same signature, to essentially have a function that accepts the same parameters and just have different implementations. Okay, so let's go ahead and thread them anyway. Okay, so we're just gonna put them into Lambda expressions, and then we're gonna go over why that can be a problem. So for the try function, let's go ahead and wrap this bit in a Lambda. We're going to do the same thing here. just like that. Let's go ahead and run this, and here you can see that we are trying first, and then starts executing first function, ends, and what we can actually do is, let's go ahead and interchange these, okay? So you can see that the other one starts, trying, executes. So this is kind of the thing about the functional programming, is to be able to sort of switch around, change the order of your middleware. That's all that middleware really is. But the main problem here is, at the moment, this type of middleware is kind of on crutches. The primary crutch that I want to talk about is this Lambda function. So what happens when you compile your C# code, what it's going to do with these Lambda functions is, if I drop these down, what it will do is it will say, right, this function right here, this is actually not real, and we need to convert this to an actual function to exist. So what it will do is it will create a local function, and it will just say something like lambda for first, and what it will do is it will essentially say, right, let's just execute this here, okay, and it actually passes a function as a parameter here, all right, and for the second one, it does the exact same thing. So second, it will grab this try, it will put it in here, we'll grab the lambda second, I'll pass it as a parameter, okay. So this is what it does. What it does is it creates this debris. So this debris is the primary crutch of our middleware right now, and the primary problem of why we can't sort of chain these. So what I'm going to do is I'm going to copy this workspace and I'll switch between the two. But essentially, let's go ahead, copy this, and what we will do here is we're going to add a little bit of parameters that we can use, right? So let's go ahead and say string message. So we're gonna try to pass messages to these. So essentially, we will have some piece of data that we want to put through our middleware, right? It's not just executing some functions, void functions. We have a carriage that we have a package that we're gonna push through the pipe, and then something's gonna come out on the other end, and we want to do with that as well. Let's go ahead and provide some parameters and utilize these parameters. So I will move this string into here just so it looks pretty and we know which function we're executing. Let's go ahead and say message here, and we're gonna say message here. I'm gonna remove these lambdas because they don't really serve that much purpose here. I'll do the try again on here, and the lambdas, they don't exist. And let's actually start a clean. What we want to do now is, because essentially the signature changed, so we have to change the signature of our action as well. Okay, so what we will try to, if we try to wrap our second function, it will no longer happen. All right, so we wrap our second function, it doesn't happen. Okay, so what we can do is we can do this like this. So let's just pass a number 2. But again, with the lambda bit, we are putting our middleware on a crutch, essentially. Just remember that the lambda here is the crutch. All right, this is not something that we want to do, especially because this number 2 is our package and we're not actually putting it through the wrap. We can't do anything with it if it's just in this lambda function, right? So what we want to do is we actually want to receive our message and do something with it, and then actually put it inside this function. Okay, so once we have this message, we can say that we are starting, and we'll just dump the message here, and then we'll pass the message. I'm just going to keep ends as ends. So what happens now is we can go ahead, pass the 2 here, and still have the function with the correct signature passed here, right? And then we actually consume it inside the wrap function. Now, again, coming back to the middleware point, is that the signatures of the middleware components kind of have to stay the same. So let's go ahead and copy this signature, put this here, and we're going to do the same. We're going to just pass the message here, and we can say trying here, and say message. Okay, don't need to save that. And now if we want to wrap this, again, this is where chaining this can become a problem, and we will have to put this on crutch, unfortunately, because this signature right here doesn't match this signature. For this signature, we accept a message and an action. Here we only accept a string. So this is how we would do this. We would still pass the two, but then we would say that in this lambda, we're going to be essentially creating a message here and passing it here. Okay, so the message that we're going to thread in, we're going to put into try, we're going to say, right, message once try is done, you're going to then thread it into wrap. Okay, and this is once we execute this function here, this is when it's going to put it into the wrap. But remember that the lambda is converted into a local function. Okay, so again, we're forced to use this crutch. And we can try to execute this, and you can see that it's pretty much working. Now that we're sort of at a point where we can understand that this lambda is a crutch, and if we try to essentially build our pipe a little bit more, you can imagine how atrocious it's going to look, right? So you can see that we have to supply a lambda here, and if we go, let's say, one more level, okay, try 2. So we're going to try 2, where we're now going to be passing the 2. And here we're going to have the message, where in here, we're now going to have to pass it here. And the scope is going to be changing as well. So this is going to be message 1, where we're going to have to be passing message 1 here. And this is going to be message 2, where we're going to be passing message 2 here, right? So this is not ideal. If you want to create a pipe like this, for example, the real message is here, and we want to pass it into here. And this is going to be our var pipe. And I guess action string. Okay, you can see how this is not the best way to represent a pipe, right? So if we say pipe 1, all right, you can see the pipe is working, and we can store it as a variable, but it's not the best way to declare it. If you ever used callback functions, this is essentially what this is. This is callback function health. So this is where we're essentially going to try to use object orientation and try to thread these functions through each other. And here I'm essentially going to try to replicate what ASP.NET Core middleware does. Okay, so here we are. Let's go ahead and remove this. We will still have our first function and our second function, where we're going to accept parameters as strings, although it's not so important. What we really want to do is we want to have these wraps and tries converted to middleware. So let's go ahead and add some structure first. I'm going to create a public abstract class. The reason I want to abstract class and not an interface is because I want to define a constructor that should be fulfilled. So we're going to have a pipe. Just like that. So the primary thing that I want in my pipe is a constructor with the action. And essentially what I'm going to be doing is I will have a pipe, okay? And if I have one pipe in my middleware, that's the end of the story. I put the action in there, all done. If I have a second pipe, what will have to happen is that the first pipe will essentially have to go around the second pipe, okay? And that's this function right here. Essentially, you can see how the action is in the middle of this pipe. And again, the function here is in the middle of this pipe, okay? So it goes in, and then it goes into the next pipe, and then it comes out, all right? There's a bunch of pictures on the internet about middleware. They pretty much explain the flow of this. It's quite easy to understand. Here we're going to really dig in here. So when I create my pipe, I want to make sure that it knows which next pipe to call. Okay, so what the action is going to be is a handler on the next pipe. Okay, and the handler is going to be this action. So constructor, we're going to have an action where we're going to accept a string, and it's just going to be an action. Okay, let's format this a little bit. let's go ahead and assign this action to an action. I'm just going to create a field of action here. Okay, so my pipe now has an action that it can use, and I'm going to give this a protected, so anything that inherits from this can actually use this, right? This is not so important, but nevertheless. Next thing that I want is to be able to consume the message and do something with the message. So the way that we do stuff here, I want to be able to do that with this message as well. So what this handle will have to be is essentially a handle that can be put into another pipe. So here, let's go ahead and create a public void because it's an action, and we're going to consume a string, right? So let's say handle string message. So we're going to handle a message, and because this is an abstract class, this is going to be an abstract function, which is something that inherits from the pipe we'll have to implement. Okay, yeah, I don't want to save it. Let's go ahead and implement a wrap pipe first. So let's go ahead and say public wrap, and whoa, this is going to be a class pipe. Let's go ahead and bring in our implementation. We are going to go ahead, copy this bit. We're missing the function. Well, it's all right. We have the action here instead, right? Which we're going to be putting into the constructor. And for the wrap, let's go ahead and grab our constructor. And I'm just going to actually copy this signature here. I'm going to pass it to the base. Okay, so when I pass it to the base, it's going to be put back into here. I'm going to collapse this one here. And let me just format this a bit. Didn't really want that there. Okay, so that's the wrap function. I'm okay with that. Let's go ahead and do the same for the try. I'm going to copy the wrap. I'm just going to rename a few things. So try, handle stays the same, action stays the same. The thing that we do with the action changes. Okay, so all we do is we implement a different handle for the middleware. Okay, try to doesn't need to exist. Okay, we can create a different type of middleware if we want. So we have two middlewares that essentially do the same thing. Now what we want to do is create some sort of a builder for this pipe. Okay, and this is what I'm gonna do. And actually, I think it will be a little bit easier if we look at the pipe while we build this. So I'm gonna create a pipe builder, where the first thing that we want to be able to do is add a pipe or register the primary thing that we want to execute. Do we want to execute the first, or do we want to execute the second, right? What do we want to execute? So this is something that could be done in the constructor. And again, the signature matches this, as well as the handle matches this. So again, going back, right, nope, not in here, in where you see the wrap, you can see how we call the wrap. The handle is different from the function that we're executing. Here, the handle has the same signature as what we're going to try to execute, okay? So it's void, and it has a string, right? So they're essentially kind of the same function. They can be used in the same places, but what they actually do is different. All right, so in here, I'm going to accept an action with a string, and this is going to be action, or let's call this main action. Let's go ahead and make a global private here, main action, boom. So we pretty much know what we want to execute in the end by specifying this. Now what we want to do is be able to add pipes to our pipe builder. And because essentially what's going to happen here is we cannot pass instances of types. So when we create the pipe, we already need to know what action is going to be going in there. Okay, so we need to know all of our pipes before we build the whole pipe. Okay, so what we're going to do is we're going to collect all the pipes that we want to register first. Let's go ahead and add void, add pipe, and here we're going to make sure that we supply a type of pipe. All right, so a type is a class that represents a type of an object. So if I would type of string, this essentially is going to give me a type of string, right, where I can go ahead and inspect all of its different properties. But essentially what we want to do is kind of do a little check. Is this type a pipe? Or like, let's say that it's a pipe type. But so what we would do is we would say if pipe type get type info and is instance of type of pipe. So what we're doing here is we're essentially checking, right, whatever type we're supplying here, is it an instance of pipe? Because what we're doing here is we're going to be providing types of wrap, and we're going to be checking, right, are they actually pipes? And coming back here, looks like I missed one curly bracket. Okay, so here we're going to just throw an exception. I'm just going to put a breakpoint here, so in case I hit that, I just want to be able, I want to be the first to know. Otherwise, let's go ahead and collect all these types. So list type and pipe types. Okay, and we can initialize this from the constructor. Not like that. New list type, just like that. What we want to do here is just say pipe types. Add pipe type, boom, easy, right? We're just collecting all the types of pipes. The hard bit is now essentially assembling them, right? Which is not really too hard, but it's hard if you never use the activator. So every builder has a build function, so let's go ahead and create a public, and all it's going to be is this action that we want to return, right? So we want to return an action, build. Okay, right there. So how do we construct this function? First of all, let's consider that we're gonna get a type from our list. How do we create an instance, right? So var pipe, you use something called the activator. So an activator, what you do is you can create an instance. So you will essentially provide pipe types. You will provide a type of what you want to create, and then you can specify some arguments, okay, for the constructor. For our constructor, we would have an action of type string. So for the last middleware, the middleware that is actually going to be executing, so coming back to the first example, in this example, the last middleware here is wrap, and the last middleware, or actually, here the last middlewares are whichever ones in these lambdas. So wrap is the list middleware, the one that's actually going to execute the function that we're wrapping altogether, okay? So here is where we're going to be putting the main action, okay? So if we put this in the first, so let's go ahead and get our pipe, which we're going to get from our pipe builder, where the action is going to be first. We're going to go ahead and add a pipe, where the type for that pipe is going to be, let's say, we will preserve the same original order for try and then wrap. We would be doing type of try, not like that, try, and then we would add another pipe, type of wrap, and these aren't chainable right now because I haven't made them chainable. I will need to, from add pipe, I will need to return a pipe builder and return this. Okay, so now they're chainable, but at the end we still kind of don't get a pipe. We want to just return null here, and at the end let's go ahead and just build this. Okay, so this at the end will be the pipe. So if we first add the try and then we have the wrap, what we have in the list at position 0 is try. So if we put the main function in the try, and then we have the try function, which inside of it in the constructor we have passed the main action. So a try function is holding the main action. So if we then, whatever we have that instance, if we put it inside the wrap function, the order is not preserved because it will execute the wrap function first and then the try function and then the function that we essentially want to execute. So let's go ahead and kind of turn the wheel. We want to reverse the order. So instead of supplying the first pipe that we want to create here, we want to try to instantiate the first pipe and passing as a parameter the second type. Okay, so the way I'm going to achieve this is I'm going to create a private action string, because remember, the actual thing we're putting into the constructor of the pipe is a handle of another pipe. Okay, so we want to basically create a pipe, the last pipe that we add. We want to grab that pipe, put the main action in that pipe, and then use the handle of that pipe as a parameter for the pipe that's going to wrap that. Okay, so can be a little bit mind-boggling, but as we work through this, hopefully it will make more sense. Create pipe right here. So what I want to do is I want an index of all my pipes. I want to basically know which pipes I'm going through. This is where I'm actually going to be creating these. So I'm only gonna instantiate the main action when I've reached the end. Otherwise, I'm gonna go ahead and try to create a pipe. So if index equals pipe types dot count, right? So I'm reaching the end of my pipes. If I have 2 pipes the way I have now, what I want to do is go essentially this, but on the last one. So no, we actually won't be able to reach the last pipe here with the index being overflown. So let's do a little bit different, right? So while the index is less than the count, we're actually in range for creating, basically, we're in range for inserting one pipe into the other. Otherwise, once we're out of range, we want to return the pipe with the last index. I think I'll still need a -1 here. Let's go ahead and do that. Yeah. So once we create the instance, let's actually put this into a var final pipe, because this is going to be a pipe, right? We want to convert it. And what we're actually returning is the handle. Just like that. Okay, so this will happen at the end. Before this, what we want to do is start creating this pipe right here. So we want to create the pipe starting at 0. So when we're at 0, and this will be 2, -1 will be 1. So we will be at our first one. So this is where we'll hit this. What we want to do is we first want to instantiate the child pipe, the pipe that is going to go into this pipe. So child pipe handle. The only reason I'm calling it handle is because all we're doing in this pipe is we're returning handles, right? We're going to combine all these functions. I'm sorry I'm rambling on so much, but I'm trying not to miss too much information. I know this thing can be confusing. What we're going to do is we're going to create a pipe, because we know we will need that to pass that index right there. Okay, and this will bump it up to 1, and this is when we're going to reach that final pipe, and we're going to return that pipe from here. Okay, so this is a recursion. I'm using a recursion here to essentially instantiate things before instantiating other things. Let's go ahead and actually grab the pipe, and here we're going to use the activator, and we're going to grab the pipe types of the actual index that we're using. And remember, the index that we add the number to this index isn't actually incrementing this index. We're just basically grabbing the next type, but we're going back into this function. So if the same instance occurs, again, we're just going to grab the next type before instantiating this pipe. So essentially, we are grabbing the last, if I can get in range, we're grabbing the last, or this will be the start. We're grabbing the last pipe and then creating the last pipe, putting into the previous pipe, into the previous, into the previous, until the very first pipe. Okay, this is essentially what we're doing. So again, we're going to use the activator to create the instance, and the action that we're passing here is the child pipe handle. Okay, and then we finally have the pipe, and this is, by the end, this is what we want to return. We want to return the pipe handle. And again, we'll just need to cast this right here. Okay, and not actually call it. We will essentially create a pipe from the beginning, and we'll have the pipe at the end, and can just return this. And this can be simplified. The build can start with a 0 and call itself, and by the end return the pipe. But hopefully you get the picture. So let's go ahead and try this thing. First, build pipe. Yep. What do we want to say? Pipe. Hello world. Or just hello. Hello world's too far. Go ahead and run this. Looks like I'm hitting an exception. I clearly don't know my reflection checking. I'm pretty sure this is correct though, so I'm going to remove that. Okay. So you can see what we essentially did is create our own pipe with the middleware. So now we can nicely chain these functions, and that's essentially what's going to be done in the middleware. We don't have a abstract class that we inherit from in .NET Core, but here what we essentially do is we give it a little bit of structure, and the check there that you can perform if you have time to look up the code. I don't want to. You can do that, but you can see that it works, and you can type the world here. We can try another one. Okay, you can see that it's essentially middleware that's reused. That can be stored and can be declared in a reasonable manner. We're not building staircases, okay? We're building walls, all right? Walls of code. Yeah, this will be it for this part. Let's go ahead into Visual Studio. Here we are in Visual Studio. Essentially what I did, I knocked up a little example of a custom middleware component in .NET Core, and we're going to go over how to add this component to the pipeline, and essentially some other possible methods we can use to actually implement middleware. So taking a look at this custom middleware piece, some components should stick out to you, and you should be able to recognize them as the middleware building blocks. For example, the request delegate, the fact that it has a delegate on the end, you don't necessarily know what function it is, but since it's going to be invoked, you know that it is a function. If we press F12 on it, we can see that it's a delegate that has a signature of returning a task, and the package that we're essentially passing around is the HTTP context. Okay, so this is what the function will expect, and this is what we can return. And essentially, the custom middleware component, the invoke function, is essentially a request delegate as well, right? So this is pretty much the same exact solution that we've written in our linkpad script right here in the custom middleware component, right? Where we have a pipe, we're going to be passing the delegate. All they did is replace in the action, they put the HTTP context here, and they actually made it a function by making it return a task. Okay, and they put the HTTP context here. Alright, but nevertheless, it's almost the same thing. And again, the handle, their signature pretty much matches here, except instead of void, they return a task, and here they pass the HTTP context. Just understanding that the middleware is a function wrapped in another function. So understanding this concept will allow you to know when to use middleware, okay? For this reason, I'm not going to be showing you any actual real-world implementations, because as long as you understand this idea, for when the time comes for you to actually use the middleware, it will become apparent because of some use case or some functionality that you're trying to implement. So if we have this custom middleware piece, the way we do it in our linkpad script, we essentially just add it to the pipe, and this is pretty much the same. We have our iAction builder, and all we do is we say, right, let's go ahead and use our middleware, where we provide our custom middleware, and this is pretty much the end of story. These use routing and use endpoints are just functions, static functions that have the iApplication builder, which they extend, and they're just pretty little bits of code that you can wrap your ugly used middlewares in. Okay, so some other ways that .NET Core allows you to inject some middleware is through the use function in the middleware, and there are two overloads for this. So the first one that you will see is func that accepts a func request delegate and returns a request delegate. Okay, so again, this is this function here, and notice that in the request delegate you don't actually have access to your package. So here we're gonna have a request, and we're gonna return a request. Okay, so this middleware is all about do something before request. Okay, so this way we are essentially doing something before we execute the request, but we don't have access to the HTTP context. Alright, another bit of the use function that we have is if we go into the use, and you can see right here there is one of two overloads, and if I press up or down I can scroll through them. So this is the request delegate, this is the second one, and the first one is a func of HTTP context and the func of task, and it returns a task. So the signature is essentially we accept a parameter of HTTP context and a function that returns a task, and by the end of this we have to return a task. Okay, so we have the HTTP context, and then we have the function, and what we do is we return a task, but this function is going to be returning a task. So essentially what we're doing is we're returning a function here. So with this middleware we can do something before, and then if we want to do something after, all we can do is turn this lambda async and essentially just await on this function, and then we'll have the result here. And actually we can't, we can just await on the function, and this will be something along the lines of calling this next function, but without actually passing the HTTP context to it. So this one is a little bit weird, but nevertheless it is pretty much the same, but just without having to pass the HTTP context into there. And then we can still do something after. Okay, so these are the options that are available to you. Which one to use you will know once the situation arises. As long as you understand middleware, you will be able to implement it. So the first part is very crucial to how we implement it, and again the basic concept that it's just functions wrapping other functions. Okay, and basically another thing we can look at is the HTTP client. So this will essentially allow you to inject an HTTP factory, where then you can spawn a client with some sort of name. And for this, the one little gotcha is if you just add an HTTP client, you can't get an HTTP client builder. So you really want to get an HTTP client builder to get a hold of the add HTTP message handler middleware, right? Not middleware, sorry, function that will allow you to add a type of the middleware that you want to apply to the HTTP client. So with the HTTP client, it's a little bit different. Because here we essentially have this HTTP context that contains the request and the response. Okay, so it's like we're passing this container with the request and the response, and it's just this container going around. In the HTTP client middleware, we have a task of the HTTP response message, but what we accept is the HTTP request message. Okay, so we send the HTTP request message, and before we actually send it, again, we can do something before it and we can do something after it. It's the same story. It's just functions wrapped in other functions. You can remove the task here and just return the base here, right? And then you don't get to do something after this. And the main difference between this middleware and the HTTP client middleware is that we are actually inheriting from the delegating handler. Okay, and this is what the delegating handler is. Primarily, it wants you to implement this send async function, and that's all that there really is to it, right? Again, the concept is really being able to understand the concept of function wrapping another function. All these implementations of middleware are actually easy to implement yourself if they don't exist. If you need to wrap some sort of functionality in other functionality, you can now create your own middleware because of what I showed you before, but essentially this is how you would do it for .NET Core. Now let's go ahead and take a look at Axios and the Angular HTTP client and their interceptor concept. So here we're looking at the Axios interceptor, and again the way that you can spot middleware and essentially just recognize what you've learned before is again looking for this concept of a function wrapping another function. Okay, so here we have Axios, and what we do with Axios is we say, right, let's go ahead to the interceptors and we are going to go ahead and grab the request. I'm getting some GitHub IntelliSense, which I don't want to get, but essentially for the request, we want to put a pipeline on the request. So here in Axios, we don't have middleware where we sort of wrap the request and then have access to the response at the same time. We do the requests and responses separately. Okay, so here to the request, we can add a function that where we essentially get the configuration for the request. We can do something before the request is sent, right? So again, it's a similar pattern, and then we return the configuration. So you could simplify this to being the HTTP context, okay? And then the same thing for the response. You provide a function where you do something after catching the response, and then you keep returning the response, okay? So pretty familiar concept. For the Angular HTTP interceptor, what we do is essentially we inherit from a class of HTTP interceptor, and then we get a function of intercept. We then have the request that we're about to make, right? So pretty much the same thing. The primary difference between words like middleware, interceptor, filter is just slight functionalities that they provide, but I would call it all middleware and avoid confusion. You're just wrapping functions. That's all you're doing. So you have the HTTP request, and then you have the next handler. So this is closer to our .NET Core middleware, where we can await the next handle or grab the result and still do something after and then return that result from this handle function. Okay, so we do something before and then we can return the handle, or we can store the result in a variable and then return it after. Okay, so this is a do before and do after middleware. Okay, so at this point, as long as you know what middleware is, spotting what you can do with the types of middlewares that have been implemented in your specific language or technology, right? Now let's go ahead and implement our own version of middleware in JavaScript. So here we are in VS Code with main.js file, where essentially I'm going to do something like console log a and run this file here. Okay, so let's go ahead and first define our primary function that we're going to execute. And here we're going to take that example where we have a delegate that we can do something after with the response. Okay, so it's going to be a request coming in. We're going to put it in the next function, and we're going to be able to retrieve the response and do something with the response. Okay, so the first thing is I'm just going to create a function that's going to mock out an API call. Alright, so we're going to be making an API call. This is going to be a function where we're going to be taking a request, and we're just going to return a hello plus the whatever we're passing. Okay, so we have the API call. Let's go ahead and make a simple pipe where again we're just going to do the start and end. So again, we're just going to call this wrap. This is going to be a function where we're going to have the request coming in and we're going to have the next function. Okay, so we're going to console log start and we're going to log the request, and we're going to do the same for the end. But now what we're also going to do is we're going to grab the response from the next function where we're going to pass the request, and we're going to be able to grab the response and then return the response in the end as well. So how I'm going to achieve this in JavaScript again, because this is the actual implementation of the pipe, and implementations differ from one way to another. This is not necessarily the most correct way, but is going to achieve the task nevertheless, or the solution. So I'm going to store all my pipes in this array, and let's go ahead and create a function that's going to be adding pipes. So here we're going to be passing a pipe. And what I'm going to do is I'm going to store every single pipe, and every time I store the next pipe, I'm going to put the previous pipe in it. So what I want to check is if my pipes length is 0, this is essentially where I know it's the first pipe coming in, and I'm just going to put the API call in there. And let me just convert this to a function like this. What I will do is I will use the Lambda function crutch to essentially mock out this next function call to essentially, because the function signature here differs from the pipe signature. Okay, so I want to sort of normalize the function signatures. So for the pipes, all I'm going to do is I'm going to push a Lambda function where we're going to be accepting a request, and that request is what I'm going to be putting into the pipe, into the first pipe, and the API call is going to be the function that I'm going to be executing in the next. Otherwise, we are going to use the previous pipe and put it in to the array as a Lambda function, right? So let's go ahead and copy this, and instead of the API call, we want to get the previous function. So maybe not let. Do we get a let? I'm not sure, but we'll see. So previous function, or let's actually call it pipe, and we're gonna go into pipes where we can supply pipes.length -1, and this way we get the previous pipe. And now the current pipe that's coming in for the next call, it's going to be this Lambda function that we pushed in there previously. Okay, so now what we can do is we can add a pipe wrap, and this is going to be pushed in first, and now we can also make a try wrap. So let's make a try wrap. The reason I'm not calling it try is because try is a keyword, so I'm going to be calling it try wrap. And again, the signature is the same. I'm just going to go ahead and log trying here. I'm going to do returning the response straight away from the next. I'm not actually going to be wrapping it in a try. It's just an example. Okay, so here we are. What I want to actually do is call the try first and wrap then. So I will add the try wrap first, or rather, no, I need to add it after. So then when we go to build the pipes, we're going to add a build function where we're just going to return the last pipe, because the last pipe is going to contain all the previous pipes. We want to just go to our pipes, and we want to grab the length -1 right here. I actually just realized that length is going to be a outbound, so we actually want to do -2 to here to grab the previous function, right? So a little error on my part, but we didn't run this yet, so the error didn't happen yet. So once we build, what we get here is the last added Lambda with all the previous pipes attached, and all the pipes are contained in this pipes array. So now what we can do is grab our main pipe by calling build, and for the main pipe, let's go ahead and call world. Okay, let's go ahead and run this. And actually I lagged completely, so no, never mind, this is still meant to be 1. So let's go ahead, clear this again, and let's do node. Okay, so running our application, we essentially get the trying, then we get the start, and then we get the end. And again, we can interchange these, so we can swap the order of the middleware, and we can run our program again, and you can see that the try is now happening inside the wrap pipe. So just another quick example of middleware in JavaScript. This will be it for this video. Hopefully you enjoyed it. If you did, don't forget to leave a like, subscribe for more. If you have any questions, make sure to leave them in the comments section. Don't forget to join the Discord channel, link is in the description. And hopefully I'll see you in my other videos.